According to the National Electrical Code, for a number 12 wire circuit, you must use a minimum number 12 American wire gauge equipment grounding conductor to bond the gas pipe. For a 60 amp circuit, you must use a minimum number 10 American wire gauge equipment grounding conductor for bonding the gas pipe. Therefore, you are correct in using a number 10 American wire gauge equipment grounding conductor for the second furnace with the 60 amp circuit. The equipment grounding conductor, often abbreviated as EGC, plays a crucial role in electrical safety by providing a low impedance path for fault current to return to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices, such as circuit breakers or fuses, which in turn minimizes the potential for electrical shock hazards and equipment damage. The proper sizing of the equipment grounding conductor is essential for its effective functioning. The National Electrical Code, commonly referred to as the NEC, outlines the minimum requirements for equipment grounding conductor size based on the rating of the overcurrent protective device protecting the circuit. These requirements are designed to ensure that the equipment grounding conductor can safely carry the maximum fault current that may occur during a fault condition. For a number 12 American wire gauge wire circuit, the National Electrical Code mandates the use of a minimum number 12 American wire gauge equipment grounding conductor for bonding the gas pipe. This requirement is based on the ampacity of number 12 American wire gauge wire, which is typically rated for 20 amps. The number 12 American wire gauge equipment grounding conductor is sized to handle the fault current associated with a 20 amp circuit. For a 60 amp circuit, the National Electrical Code requires a minimum number 10 American wire gauge equipment grounding conductor for bonding the gas pipe. The ampacity of a number 10 American wire gauge wire is typically rated for 30 amps, but the equipment grounding conductor size is based on the rating of the overcurrent protective device, which in this case is 60 amps. The number 10 American wire gauge equipment grounding conductor is sized to handle the fault current associated with a 60 amp circuit. The purpose of bonding the gas pipe is to create an electrically conductive path between the gas pipe and the electrical grounding system. This bonding helps to prevent the buildup of static electricity or stray voltage on the gas pipe, which could pose a shock hazard or create a spark that could ignite flammable gases. The equipment grounding conductor provides this conductive path, ensuring that the gas pipe is at the same electrical potential as the electrical grounding system. The connection of the equipment grounding conductor to the gas pipe should be made in accordance with the National Electrical Code requirements. Typically, the equipment grounding conductor is connected to the gas pipe using a grounding clamp or other approved fitting. The connection should be made on a clean, unpainted surface to ensure a good electrical connection. It is important to note that the National Electrical Code is a comprehensive set of electrical safety standards that are updated regularly. It is essential for electricians and other qualified professionals to stay up to date with the latest edition of the National Electrical Code and to follow all applicable requirements when installing or working on electrical systems. When installing a gas furnace, it is crucial to ensure that the gas pipe is properly bonded to the electrical grounding system using the correct size equipment grounding conductor. This will help to ensure the safety of the installation and to prevent potential electrical hazards. In summary, the National Electrical Code requires a minimum number 12 American wire gauge equipment grounding conductor for bonding the gas pipe in a number 12 American wire gauge wire circuit and a minimum number 10 American wire gauge equipment grounding conductor for bonding the gas pipe in a 60 amp circuit. Proper bonding of the gas pipe is essential for electrical safety and should be performed in accordance with the National Electrical Code requirements. The National Electrical Code Section 250 provides comprehensive guidelines for grounding and bonding electrical systems. Specifically, Section 250.104 addresses the bonding of piping systems and exposed structural metal. This section requires that metal gas piping systems be bonded to the electrical grounding system to minimize the potential for voltage differences and electrical shock hazards. The size of the bonding jumper, which is the conductor used to connect the gas pipe to the grounding system, is determined by the size of the circuit that is likely to energize the piping system. This is typically the circuit that supplies power to the gas furnace or other appliances connected to the gas piping system. Table 250.122 in the National Electrical Code provides the minimum size requirements for equipment grounding conductors based on the rating of the overcurrent protective device protecting the circuit. As previously mentioned, for a number 12 American wire gauge wire circuit protected by a 20 amp overcurrent device, a minimum number 12 American wire gauge equipment grounding conductor is required. For a 60 amp circuit protected by a 60 amp overcurrent device, a minimum number 10 American wire gauge equipment grounding conductor is required. It is important to note that these are minimum requirements, and a larger equipment grounding conductor may be required in certain situations, such as when the length of the conductor is excessive or when the impedance of the grounding path is high. In addition to the size requirements, the National Electrical Code also specifies the methods for connecting the bonding jumper to the gas pipe and the grounding system. The connection must be made using approved fittings such as grounding clamps or bonding bushings, and the connection must be mechanically secure and electrically conductive. The bonding jumper should be installed in a location that is accessible for inspection and maintenance. It is also important to ensure that the gas pipe is properly supported and protected from physical damage. Any damage to the gas pipe or the bonding jumper could compromise the effectiveness of the grounding system and increase the risk of electrical shock hazards. When working on electrical systems, it is essential to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and using insulated tools. Always de-energize the circuit before working on it, and verify that the circuit is de-energized using a voltage tester. If you are not qualified to work on electrical systems, it is important to hire a licensed electrician to perform the work. Working on electrical systems can be dangerous, and it is important to take all necessary precautions to ensure your safety and the safety of others. In summary, bonding gas piping systems to the electrical grounding system is an important safety measure that helps to prevent electrical shock hazards. The National Electrical Code provides detailed requirements for bonding gas piping systems, including the size of the bonding jumper, the methods for connecting the bonding jumper, and the location of the bonding jumper. Following these requirements is essential for ensuring the safety of electrical systems and protecting people from electrical shock hazards. Always consult the latest edition of the National Electrical Code and follow all applicable requirements when working on electrical systems. In addition to the NEC, local codes and regulations may have additional requirements for grounding and bonding. It is important to check with local authorities to ensure that your installation complies with all applicable codes and regulations. The purpose of the equipment grounding conductor is to provide a low impedance path for fault current to return to the source. This low impedance path is essential for the rapid operation of overcurrent protective devices, such as circuit breakers and fuses. When a fault occurs, such as a short circuit or a ground fault, a large amount of current will flow through the fault path. If the equipment grounding conductor is properly sized and installed, it will provide a low impedance path for this fault current to return to the source. This will cause the overcurrent protective device to trip, interrupting the flow of current and preventing further damage or injury. If the equipment grounding conductor is not properly sized or installed, it may not be able to carry the fault current safely. This could result in a voltage rise on the equipment grounding conductor, which could pose a shock hazard. It could also prevent the overcurrent protective device from tripping, which could result in a fire or other damage. Therefore, it is essential to ensure that the equipment grounding conductor is properly sized and installed in accordance with the National Electrical Code and other applicable codes and regulations. The equipment grounding conductor should be run with the circuit conductors, and it should be connected to all metal enclosures and equipment that are likely to become energized during a fault. The equipment grounding conductor should also be connected to the grounding electrode system, which consists of the grounding electrode and the grounding electrode conductor. The grounding electrode is typically a metal rod or plate that is buried in the earth. The grounding electrode conductor connects the grounding electrode to the equipment grounding conductor. The grounding electrode system provides a connection to the earth, which helps to stabilize the voltage of the electrical system and to provide a path for fault current to dissipate into the earth. The grounding electrode system should be installed in accordance with the National Electrical Code and other applicable codes and regulations. It is important to ensure that the grounding electrode is properly sized and installed, and that the grounding electrode conductor is properly connected. A properly installed and maintained grounding system is essential for electrical safety. It helps to protect people from electrical shock hazards and to prevent damage to equipment. The National Electrical Code provides comprehensive guidelines for grounding and bonding electrical systems. Following these guidelines is essential for ensuring the safety of electrical systems. The equipment grounding conductor provides a path for fault current to return to the source, allowing the overcurrent protection device to trip. The equipment grounding conductor must be sized appropriately based on the overcurrent protection device. The gas pipe must be properly bonded to the electrical grounding system to prevent voltage differences. The NEC provides the minimum requirements, but local codes may have additional requirements. Proper grounding and bonding are crucial for electrical safety. Always consult with a qualified electrician for any electrical work. When dealing with gas piping, it is also essential to consult with a qualified plumber or gas fitter to ensure that the gas piping system is properly installed and maintained. Gas leaks can be dangerous, and it is important to take all necessary precautions to prevent them. If you smell gas, immediately evacuate the area and call the gas company or fire department. Do not use any electrical equipment or open flames, as this could ignite the gas. Gas piping systems should be inspected regularly for leaks and damage. Any leaks or damage should be repaired immediately by a qualified plumber or gas fitter. It is also important to ensure that gas appliances are properly vented to the outside. Improperly vented gas appliances can produce carbon monoxide, which is a deadly gas. Carbon monoxide detectors should be installed in all homes with gas appliances. Carbon monoxide detectors should be tested regularly to ensure that they are working properly. If the carbon monoxide detector sounds an alarm, immediately evacuate the area and call the fire department. Gas and electricity can be a dangerous combination, and it is important to take all necessary precautions to prevent accidents. By following the safety guidelines outlined in this discussion, you can help to ensure the safety of your home and family. Remember, when in doubt, always consult with a qualified professional. Do not attempt to perform any electrical or gas work unless you are properly trained and qualified. Electrical safety is not just about following the National Electrical Code. It also involves understanding the principles of electricity and how it can be dangerous. Electricity always seeks the path of least resistance to return to its source. In a properly grounded electrical system, the equipment grounding conductor provides this low impedance path. However, if the equipment grounding conductor is not properly sized or installed, or if there is a break in the grounding path, electricity may find an alternative path to ground, such as through a person. This is why it is so important to ensure that all electrical equipment is properly grounded and that the grounding system is properly maintained. It is also important to be aware of the potential hazards of static electricity. Static electricity can build up on objects, and when these objects come into contact with each other, a spark can occur. In a flammable environment, such as near a gas pipe, a static spark can ignite the gas and cause an explosion. This is why it is important to bond gas pipes to the electrical grounding system, as this helps to dissipate static electricity and prevent the buildup of static charges. Bonding gas pipes is a relatively simple and inexpensive safety measure that can help to protect people from electrical shock hazards and gas explosions. It is an essential part of any electrical or gas installation. Always consult with a qualified electrician or plumber to ensure that your electrical and gas systems are properly installed and maintained.